I am telling about the magnetic field at the center of the current carrying circular arc. Now, questions based on this circular arc are generally asked in the NEET exam and also in some other exams. Because if we take the circular coil, then there is the simple one, but to find the magnetic field because of this one, that is not the more complicated example of this Biot-Savart's law. So now this is a circular arc. This is now suppose now center O. It carries a current I. Now its radius is R. This is now radius R. This is now center. So now if we apply the Biot-Savart's law, magnetic field at center O due to current element. This dV equal to mu naught upon 4 pi into I dl sin theta upon r square. This is the formula that we have. So now let us consider here a circular arc. Here we consider a element. This is now element dl. This is now element dl. Now if we join to this one, then you will find that this angle is 90 degree. This is now pi by 2. This is now radius, that is the distance from this one. So this theta is equal to pi by 2. So now here theta equal to pi by 2. Therefore dV is equal to mu naught upon 4 pi into I dl upon r square. This is because of this current element. If we take the complete this arc, this is now suppose PQ. So magnetic field due to circular arc PQ. This is to be how much? This B is equal to summation mu naught upon 4 pi into I dl upon r square. So what to find? This mu naught upon 4 pi into I upon r square into summation dl. So now let this angle is your phi. This angle is phi. Then what we have? This circular arc, this angle phi, and we know that angle equal to arc upon radius. So what do we have? Let phi equal to angle subtended by arc at center O. Then what we have? Angle equal to arc upon radius. This is our simple formula. So what we have? this phi is equal to, then this arc is what? The length of this arc. This is now your summation dl. Summation dl upon radius. This is now your arc. So what we have? Or summation dl is equal to phi into r. So now in place of this we can write down to this one. So what we have? Therefore B equal to mu naught upon 4 pi into I upon r square into phi into r. So this r will cancel by this one. So we will have B equal to mu naught upon 4 pi into I upon r into phi. This is no expression. This is not required expression. So this is what we are having the meaning of this when we are given the value of phi. So you can take the value of phi for different arcs. The magnetic field at center O, B equal to mu naught upon 4 pi into I upon r into phi. Now I will give you some example, special cases. Now suppose you are given a circular arc like this. This I am taking the center. This is now circular arc. This is now radius arc. It is carrying the current. Let the current is here to be now I. So this is the 1/4 part of the circular coil. So this angle is pi by 2. So now again we can have to this value. So the here phi equal to pi by 2. Angle equal to arc upon radius. So phi equal to summation dl upon r. Summation dl equal to phi r. This is not so much. So now this b is equal to how much? Mu naught upon 4 pi into I upon r. Now this angle is pi by 2. Pi by 2. So what we have, this pi and pi will cancel. So this is equal to mu naught I upon 8 r. This is not so much magnetic field. Now for this is now for quadrant. This is the quadrant. Due to one quadrant. Of circular coil. Suppose we are having semi-circular coil for semi-circular coil. What we have? Then this is now your semicircular coil, this is now center O, this is now radius, this so much, this is now carrying the current I, this is so much, then this angle is how much, this is now your pi. So you can have here this phi equal to pi, here phi equal to pi, therefore B equal to mu naught upon 4 pi into I upon R into pi. This pi and pi will cancel. So what we have? This B is equal to, this is now your mu naught I upon 4R. This is not like this one. If suppose the coil is in different cases, this is now your pi by 2 and this is we are having this semicircular coil. If suppose we are having this like this one, this is now coil, this is now like this, then what we have, that this angle is equal to 3 pi by 2, this is now carrying the current I, this is now center O, then what we have here, this phi is equal to 3 pi by 2. So B equal to mu naught upon 4 pi into I upon R into 3 pi by 2. Again we are having this pi. So in place of phi we are using this 3 pi by 2. This is not so much. So we will have this pi and pi will cancel. So this is now 3 mu naught I upon 8R. This is now your B. If we take the complete circular coil, suppose we are taking the coil like this. This is now simply, and this is now carrying the current I. Then the angle at this that will be now phi. Here phi is equal to 2 pi. So B equal to mu naught upon 4 pi into I upon R into 2 pi. So this 2 pi will be cancelled by this one. So B equal to mu naught I upon 2R. This is not so much. So this is what the magnetic field, because they were circular arc. But suppose we are given some other different cases. Suppose you are given this situation. This is now center O. It carries the current I. You would find the magnetic field at this point O. This is now current I. So at the point O, the magnetic field will be because of two parts. One the straight part, this one, and second this circular part. So this circular part has the radius R. This is now radius R. So B at O, B at O is equal to B, because of this part, state plus B due to this circular part. So because of state part, this magnetic field is 0, because I have told you that the magnetic field along the current carrying conductor is always 0. And this here, this is the half of this complete. So this is your mu naught upon 4 pi into I upon R. Now this angle will be pi. This is not so much. So just you have this, and then this will come out to be mu naught into I upon 4R. This is the magnetic field B. Similarly, suppose you are given the different cases, also one more different case I am taking here. Suppose I have this circular arc. This is also circular arc. This is carrying the current. This is now center O, and they meet at this point. This is now suppose the center of these two parts, and they carry the current like this one. In this way, then what we have, the magnetic field at this O is due to this arc, and because also this arc, but because of these two parts, the magnetic field will be 0. So let us have this now P, Q, R and S. This carrying the current I, and definitely the radius of this one is R1. This one is R1, and that of this is to be now R2. This radius, this is now your R2. So, magnetic field at O, magnetic field at center O, what we have? B equal to B PQ plus B QR plus B RS plus B SP. All the four parts. This part, this part, this part, and this part. So what we have? Now both the arcs are making the same angle. This angle is the same for both the arcs. That we are having. But radius are different. This is not radius R1, this is not radius R2. This is not like this one. So B equal to, this is now your 0 plus, then this so much. Now direction because of this element. Just you are having this in this way. This is the direction of the current, then these fingers will give the direction of the magnetic field. So we are having like this. This is now, so this is vertically outward, and because of this, this is now in this way. So these fingers are inside this place plane. So this is just vertically inward. So what we have? B equal to, this is now your mu naught upon 4 pi into I upon R1 into phi. This is like this one. As I have told you, like this. The current vertically outward. Plus, then this is now 0 because of this RS part, and then this is now your mu naught upon 4 pi into I upon, this is now your R1. This is R1 into phi. So, what we have? This B equal to mu naught upon 4 pi into I upon R2 phi minus mu naught upon 4 pi into I upon R1 into phi. So phi is what? The angle. So now this is equal to mu naught I into phi upon 4 pi into this is now your 1 upon R2 minus 1 upon R. The field that because of this one, this now magnetic field because of this one, this is the direction of current, like this. So this will be inward and this is outward. So definitely you will see that the value of this R1 is more than this to the value of this because of this QR. So this is now magnetic field B. This is now magnetic field. Or you take this to be now positive and this to be now negative, then there will be whichever is more, that we have to subtract. So definitely you take this to be now negative, batteries, this is now negative, this is positive. So this is now negative, this is now positive. So we are having this 1 upon R1 minus 1 upon R1, like that. So this is the method how to find. If you are given the angle of phi here, then you can find the value of B. So this is how to calculate the magnetic field at the center of the current carrying circular loop. So thank you very much.